Hello, good morning, everybody. Kindly confirm if you can hear me well.
Yes, good morning, sir. Yeah, I can hear.
Okay, okay. Okay, so we'll begin in another couple of moments. Yeah. All right. So, so guys, can you confirm if you can see my screen?
Yes, sir.
All right. So, guys, do you have any questions, any doubts in the last lecture that we were studying? It was a very important topic that we were having a discussion around, which was basically the VM migration. And we discussed about how the VMs can be migrated from one particular server. When I say server here, so I'm meaning basically the hardware box to another hardware server, another hardware box. And we discussed the live site migration. We discussed about the cold migration, and when we discussed about the live host migration technique, where the goal is to have the minimized downtime as much as it can be possible. Then we discussed about migrating the memory, and then with the various approaches of pre-copy migration and then post-copy migration, something the topic that we have discussed today. So, do you have any doubts, guys, before I proceed to the post-copy migration? I'll take any questions if there are any. All right. So, guys, earlier we discussed about pre-copy migration. Now we're just going to discuss about the post-copy migration technique in which the virtual machine is basically freezed first. And then the CPU state and the minimum state which is required for the virtual machine to get started is in the target server is transferred to the destination target server. The CPU state which is absolutely required here because any request which shall come after this particular thing, it needs to be addressed for which the CPU state is really very important. Okay. And then comes the minimum state of the RAM, where the recently accessed pages shall be copied to the destination. Now, as soon as the copy operation to the destination is completed, you basically start the virtual machine on the target. But what happens? What is that? It does not have. It does not have its full memory. Right? What it has is it has minimum of for it to get started. As this particular virtual machine starts getting its requests, meanwhile, the memory is also concurrently getting transferred to the target. And whenever there is a request which is come, there happens a page fault. Page fault means there is a request for a particular page, but that page is not available in the RAM memory. So whenever there is a page fault, then it has to get that page from the source. This is also called as, guys, the demand paging. The demand paging means if some particular item is not present into the RAM memory, then you has to get that same item from the hard disk. You have to get that same item from the hard disk. This is what the demand paging means for a single system. But here we are talking about the copy operation from one server to another server. So whenever a page fault happens, the page fault request goes to the server, and from there it picks the required page and sends it back. So here what is happening? As the server is up and running, guys, the demand paging is also happening. And the source is also pushing the required files actively to the target. So here, give me one moment, guys. All right. So guys, here we were talking about the demand paging. So now, as you can see here, so basically, here basically what we are telling is that the studies to us have shown that before the demand paging comes into the picture, what does the demand paging means? Before the page fault tends to occur, most of the transfer would have got over from the source to the destination. So as you can see here, the preparation time is nothing but the downtime. Downtime is because of non-pageable memory. Okay. Earlier because it was dirtied memory, but here it is because of non-pageable memory because it is not there. Because the page has not been found, the page fault occurs. And because of this reason, you have to go for the demand paging over the network. Okay. So advantage here is, my dear friends, that each page is only transferred once, only once. And therefore, we can say that the migration time is deterministic in the nature. Okay. So earlier we went through the problem of the dirtied page. Here we don't transfer everything as such because your minimum state has already happened. The requests are not going to the source, but the requests are definitely coming to the destination. Since the request is coming to the destination server, the destination is creating the page faults. And because of the page faults, my dear students, the demand paging is happening, and all of these pages, whenever they were demanded, they only come once. So basically, they get updated in the target itself. And that's what not happened in the pre-copy migration. What is the disadvantage of this technique? There is a little cold start penalty at the destination, and if the migration of the VM fails, then of course the virtual machine itself is lost. Because as soon as you free the VM, you try and push all the requests to the destination. Okay, so there is a little penalty from the cold start point of view because you have to have your VM which is available at the destination in order to be able to handle to all the requests which have started to come onto the new machine. All right, so there is one more technique here which is also called as the hybrid pre and post copy technique. Here what happens is that it combines the benefits and the drawbacks of both the techniques. Okay, here we basically start with the pre-copy round. Whenever there are dirtied pages, whenever there are dirtied pages, they will get copied as such. Okay, then there shall be the downtime because of non-pageable memory, and then post-copy pre-paging also happens. Okay, so so that's what about the guys the hybrid pre-post copy technique. All right, so we saw the migration of the memory. Now we would also see the migration of connections. Now, my dear friends, it can so may happen in two scenarios. One within the LAN network and another within the across the WAN. Within the LAN network, if the network connections it all has to be migrated, the virtual machine which is migrating, it will also carry its IP address, MAC address, all its protocol state, including the open sockets, etc. So it is a memory snapshot of the virtual machine, and it carries all of it to the destination server. Okay. Now once it has carried, the host is different. So basically, the network is going to switch. Network speeches have to relearn. That is, they has to backward learn. Why? Now because the switch has to relearn the new locations of where the virtual machine has migrated. So it knows the MAC address. but it also has to know that this particular MAC address server is present on so and so host. So how do I get to know the IP address? That is being done using the address resolution protocol. Using address resolution protocol, we can get to know from the target host so as to which server is present in which host. So as soon as this information comes, all the intermediate switches which are there, they are going to get this information and they are going to learn about the target server very fastly. Okay. Now, so as soon as this information comes, all the intermediate switches which are there, they are going to get this information and they're going to learn about the target host very fast. Okay. In this process, there might be few packets which might get lost because they were not able to find the server that is the target host because these steps were happening. ARP message was sent, its reply has to come to the host. So all of these things are happening now across a WAN network, that is wide area network. Now here what would happen is the IP address with which the VM is going that might not really suit the destination subnets. Okay. Now here, if at all they have to continue with the same IP address, then they have to try and have some kind of a tunnel using the VPN and then keep the network's connections active. I hope migrating the network connections is clear to everybody. Is there any question? Is there any doubt in this? Please ask. Okay.
Hello, sir. Hello.
Go ahead, please go ahead.
Yeah, sir. For the migration, did we use the lift and shift approach, like the line switches? All they are creating the tunnel between the on-prem and cloud, and use the lift and shift approach. Is this is correct understanding?
You're asking in the context of the network connections?
Yeah, with the migration network connection. Yeah, yes, sir.
Very good question. So see, just understand it from the fundamentals. So what happens is the lift and shift is something like a general, basically, rehosting basically approach where you take the existing virtual machine and you move it to the different data center or a different cloud or a different net server as such. Right. So this basically applies to the compute, storage, and the basic configuration. Now, in the case of the network connection migration, the lift and shift approach is not used. Why? Because it cannot migrate network routing. The lift and shift cannot migrate IP address mappings, VLANs, firewalls, security groups, DNS, etc., etc. Right? Therefore, I talked about in this particular slide that how your network connections are migrated is using the various approaches that you can take. For example, you can talk about recreating the network topologies. You can talk about reassigning or recreating the IP addresses, right? You can just talk about like updating the application connections in the database or in the API endpoints. So that can be various practical approaches when you are migrating the network connection basically. So to answer your question, lift and shift is not used for the network migration. It is only it is only used for the VM migration. But network migration would require you to perform the re-architecture for the destination server in the cloud or the destination server in the different data center or the destination server in the different server itself. Okay. So if you're migrating a virtual machine from on-premises to Azure, then in that case your lift and shift approach would lift and shift the virtual machine using, for example, like you have Azure migrate, etc., etc. And then you would have, for the network, you would have to rebuild the network in the Azure. For example, you'd have to create your own VNet, you'd have to create your own subnet, you'd have to create your own network security group, you'd have to configure your routing, you'd have to configure your firewall, you'd have to update your DNS, right? So all of these things you would have to be manually recreated, reconfigured, and re-architected in the case of your migration. Does it make sense?
Yes. Okay, got it. Thank you.
Okay. All right. Any other questions, guys? All right. So, guys, now moving on to the storage. The storage is the hard disk storage, basically HDD storage, which needs to be transferred. Okay. So, of course, here as well, it can happen for the LAN as well. Okay. So, don't get confused in that sense. If it is the LAN, especially if it is the live migration, and if the storage is outside the virtual machines, migration becomes really easy. Why? Because the storage itself would take a bulk of the time in order to get transferred or migrated to the new server. But if you have the storage outside, that is, you have a distributed storage, then the storage is being shared between the two hosts. Then you do not have to really transfer the HDD contents. This is where the NFS or the NBD or ISCSI comes to our help. These are all, some instances which can be created in the different hosts as a shared storage. So when the virtual machine gets moved from one host to another host, the HDD disk contents does not necessarily have to be migrated because these are the same shared hard disk. But if it is for WAN, then in that case you would have to take the whole image of that HDD which has to be transferred. Again, here in this case as well, we can make use of pre-copy or post-copy for the images. Okay. In order to save some bandwidth, we can even go for some type of compression as well, or the deduplication as well. So now guys, coming to the live migration technique, our assumption here is that all storage resources are separated from the compute resources. As you can see here in this particular diagram, there are physical disks which are there, fine, and there are various virtual machines which are there. So here the disks are outside the virtual machines and these are not the part of these particular virtual machines. NAS may use the NFS or CIFS. SAN may use the fiber channel. ISCSI may use network block device. So we can achieve this particular network configuration. But here the requirement is it needs to be a very high speed LAN. Okay. Okay. So we have seen the challenges of the live migration. Let us now look into the relocation strategy. Relocation strategy encompasses 5 steps: pre-migration process, reservation process, iterative pre-copy, soft stop and copy, and commitment. Some of it, guys, we have already learned it from the previous techniques, but those are all the part of the relocation strategy. Okay. Now, but during the live migration technique, what happens? It goes through the 5 stages as we have shown here. So we have the stage number one. Let's start from the stage number 0. Guys, this is also called as pre-migration, meaning there is an active virtual machine on the host A where alternative physical host is pre-selected for the migration. Guys, understand it very, very carefully because this is the live migration technique and this is very important. Here we are talking about, transferring a virtual machine which is in the running state to another host, from one host to another host without having any downtime in the real time. Okay. So guys, here what we are talking, just have a look at this diagram first. Okay. Just make this diagram understand. I'll take 1 minute pause and then we will basically talk about it more. Okay. All right. So I hope you have a mm, good understanding of this diagram. So guys, what happens here is once the alternative physical host in the stage number 0 I'm talking gets pre-selected for the migration, the block devices are first going to be mirrored and free resources being maintained in the destination host. Okay. Next stage here is the reservation, where you can initialize a container on the target host. With the requirement of the virtual machine, you initialize a container. Don't get confused with this container as the Docker container. Here we are talking about the physical space for you to host that particular virtual machine. After that, it can go through the phase of iterative pre-copy. Here what you do is you enable the shadow paging. Now it copies all the deleted pages into the successive rounds. Then downtime, virtual machine is out of service. You stop and copy the rest of it. Now you generate the address resolution protocol to the destination so that you can redirect all the traffic to the host B. And what is the remaining part? You synchronize all the remaining virtual machines. Whatever bits and pieces are left, everything is synchronized with the host B. And then comes the stage number 4, where we are basically having the commitment, where the host B is having the full virtual machine from the host A. Now host A can be released. So once it is released, the virtual machine gets activated on host B. Connections to all the local devices that resumes the normal operation. And that's how uh, this entire activation happens. Okay, so pre-migration process, then the reservation process, and then the iterative pre-copy, and then stop and copy the commitment. I repeat, first pre-migration process, then reservation, then you do iterative pre-copy, and finally you have to stop and copy the commitment. So guys, this is the pre-copy migration round 1, where we enable the shadow paging. That is, you copy whatever is there from host A to host B.
Sir,
So this is
sir,
Mhm.
I do have one question on this different stages. I notice from stage two, we are
Hmm.
going stage one to stage three directly going, and some we have to follow the stage one, two, and three also. That's direct transition from stage one to stage three in the previous slide.
1 second. You're talking about this one?
Yes. Yeah,
Okay.
there is from stage one to stage three, and there is a way to from stage one to stage two, and then come to the stage three.
Okay. So what is your exact out?
My question like when to follow the one, two, and three, and when to follow one to three directly.
Very good. So see what happens is you understand the fundamentals first. Okay. Let's talk a little bit, in a manner it will happen. So first, what will happen is you have your, let's start from the very fundamentals. Okay. So you have the virtual machine which is running on normally on the host A. Okay. And now you have identified the stage destination. I'm talking about the stage 0, guys. Okay. Now you have identified कि मेरे को transfer करना कहाँ है. So you know the destination server and you know the source server. Now your storage and your block devices can be mirrored.
Mhm.
So your what is your going to be the basic check? Whether your CPU is compatible, whether your memory is compatible, whether your network is available, and stuff like that. So exactly nothing is happening here. No data copy is happening here. I'm talking about the pre-migration. So this is basically just a check. Basically this is just a evaluation कि अच्छा यार ये हो जाएगा कि नहीं हो जाएगा.
Mhm.
Now we talk about the reservation stage. Here we are allocating the resources on the host B for the incoming virtual machine. So
Okay.
you would basically have a placeholder virtual machine which would be initialized. You would have a memory footprint reserved. You have a device mappings which would be prepared. So that is called reservation stage, where your host B is prepared to receive the virtual machine on it from the another host.
Mhm.
Now the most important stage is your stage number 2. What is that? The virtual machine is still running on the host A, but your memory pages are copied while the virtual machine continues to run. And therefore, there are some dirty pages because there might be certain pages which are modified, which would be recopied in the multiple rounds. So, shadow paging is used to track those pages which are modified during the copying operation. Why? Because we wanted to reduce the amount of the data that remains to be copied for the final switchover.
Mhm.
This is most important stage. Why? Because my virtual machine is still running at the host A and I am copying those memory pages while my virtual machine is still running to on the virtual on the host server A. So I'll have to copy it multiple times. First copy, then there would be some other new pages created on the VM on the host A. Then I'll again recopy that in the multiple second round, then third round, then fourth round like that. So here my purpose is if I have 1000 pages, then at least I should copy maximum of it. I should reduce the amount of the data that remains to be copied in the final switchover. Now coming to your question, when does the final migration happens from stage 1 to stage 3 directly? That is the transition after the stage 2 finishes, meaning the virtual machine will now move to stage 3 when the number of dirty pages becomes very small enough, like बहुत ही small रह जाएगा, like less than 5% of the total, something like that, memory. Then if you even if you copy the more pages, this is not helpful. Why? Because the copy rate is lesser than the dirty page rate. You copied 50 pages, then after you complete that copy operation, all those 50 pages, 40 pages become dirtied. Dirty means they become modified. So therefore, it is an infinite loop in which you are entering. That's why we say that copying pages is not helpful. Therefore, what we will do, we will stop the virtual machine briefly when the copying is almost complete and less than 5%, I mean. And then you would, decide that, okay, this is the time where I need to stop the virtual machine for a moment and to perform the entire stop and copy, which is stage 3. So it will come onto that stop and copy wala stage that time. And only for that moment, when the briefly it is being stopped, you would experience that the virtual machine is down. So in idealistic world, like in actual practical world, virtual machine on host A is paused, suspended. Whatever those 5% dirty pages were there, they are transferred as a delta. And then the ARP packets are sent to the redirected server, which is host number B. That's where the downtime happens for a very brief period of milliseconds, few milliseconds, which is not observable from the general human behavior. But this is where like the few millisecond downtime is being observed. And finally, I talked about the commitment stage. The commitment stage is where the virtual machine state on the host B becomes the primary state and host A पे जो भी state थी virtual machine की that gets discarded. So now host A is completely free. You can shut it down, you can turn it off, you can launch another in servers on that, whatever like you want, you can do that. And finally, you do that with this commitment and activation, you do hand in hand. So you start the host B, virtual machine is now started on host B. So it is basically resuming the normal operation and users are not able to see any considerable downtime or something like that. Is it clear?
Yeah, it's clear. Means, are we going to follow the same flow for both pre-copy and post-copy migrations?
Pre-copy and post-copy. I'm talking about the live migration here. So what is
Yeah,
pre post-copy you're talking? Pre-copy is
in a
basically,
live live migration, there is a two way to do that: pre-copy migration and post-copy migration.
yeah. So this is both the approaches are being used, na? As I just explained. That pre-copy
Yeah.
is used to copy like iteratively so that your 95% of the majority of your pages are copied to the destination server, and then your whatever is remaining, that is done using the post copy.
Okay. Okay.
Post copy is just nothing but it is just like you are transferring the stop the world fashion, and pre-copy is like when you are just doing the successive site transference from the uh, source to the destination.
Okay. Yeah, it's clear. Clear. Thank you.
Yeah, good. So this is the pre-copy migration round number one that I just explained. Stage number two, where we enable the shadow paging. That is, you copy whatever is here from the host A to the host B. Host A is the source server where the virtual machine is running, and host B is the server where we have to transfer our virtual machine. So I'm scanning both of it, and when you keep scanning both of it, these two pages gets copied. Okay. Now it saw some six of it, and these were copied. And in the diagram I'm talking, guys, the orange ones. Now, as you can see, this shadow paging says that whatever is present in host A, everything is present in host B. This is the first round, basically, that we are talking about. The first round, okay? Now, there comes the round number two. Now, these two pages have got dirtied. That is the ones which are in color orange. Now, these four pages have also got dirtied. These are the ones which now again needs to be copied. Okay? Now, that is how this round would keep on happening. Here I have shown only two rounds of such operation, but there might happen little more rounds depending upon like what is our approach. Finally, as I mentioned, this is the stage number three, my dear students. We have less than 5% of the pages which are to be copied now. This is the stop the world fashion. Here, it is a brief pause of the virtual machine that you would have to take, which is also called a stop and copy the operation. Here, your host B is ready to host the virtual machine. So you stop the virtual machine on host A and copy all the remaining 5% pages to the host number B. Okay, that's about, guys, the live migration technique. If you have any questions, please ask.
So, in the last stage when we switch off the source A and I'm kind of switch over is happening. During that phase, I believe few requests will not be served, right? I mean, says some web request is coming in. So that downtime and I mean the switchover that phase, few requests will be lapsed, right?
Yeah,
And that we have to bear with.
yes, yes,
Okay.
exactly. So you're right, absolutely, because there is a brief pause, the world session is there, and because there is a stop the world is happening here. So of course, yes, some downtime is always expected, and and but usually the this typical downtime is ranging from milliseconds to few seconds. So this may not be really minimal. This may not be really very heavily observable, and something which is like worth catching up. But of course, yes, there would be the downtime. So basically, all the cloud server providers, CSPs, are doing this under the hoods. You will not come to know about this, right? Because the virtual machine migration is the need of every cloud service CSP provider. चाहे वो Azure हो, if it is, whether it is Google, whether it is Amazon, AWS, everyone will do that because I told about the reasons of doing the migration in the last class. So, so uh, just to minimize this downtime, the people basically pre-provision the network, they lower the DNS, lot of things they do. You can study about it more details on the Azure website. So how Azure can migrate and manages downtime without a big downtime to be visible to the customer. Okay, so it is a
Yeah.
near zero downtime, but not exactly the zero downtime. So now guys, what I will do is I'll take you through the small introduction with the Proxmox, which is nothing but it is an infrastructure deployment tool which helps me in creating the virtual machine containers. Okay, so what is Proxmox? Is this everyone clear with the Proxmox? Is everyone clear? So guys, Proxmox is nothing. Proxmox is like one of our very important tools, or you can say it is a open source tool which is used to power the virtual machines and containers. Okay, so in the Proxmox, what you can do, you can basically create the virtual machines in the isolation. So you can have like KVM based virtual machines, you can have LXC based containers, and you can have Proxmox clustering also possible into the Proxmox. And most importantly, you can also perform the live migration in the using the Proxmox, where you can move a running virtual machine from one Proxmox node to another without shutting it down. So it is a free source. I mean to say it is an open source tool. So it is always free. It has a very powerful intuitive GUI, and it has enterprise features also, which is available. So therefore, it is very easily able to support both your virtual machines and container. That's why it is a loved choice, also being used in a lot of things. Okay, so guys, here you can see we have got two machine servers, and I'm trying to create the cluster of it. Just just imagine that I have got two servers. So I'm first trying to create the servers clusters. So I'm creating a cluster in the machine number one. This is my machine number one, and I ran the Proxmox tool, and this is the command I'm typing: pvcm create my cluster. So I'm creating my cluster. And here is the status. As you can see, its IP address is 192.168.0.102. This is the local. And here you can see this is the membership information that I'm basically showing. Is everybody able to see this?
Yes. Yes, sir.
Okay, awesome. Okay, so now using the IP address of the first server, I'm going to add a second server into the Proxmox cluster that I created. You see, here the IP address was 192.168.0.102. Now, I open the Proxmox 2. You see, this is the one. This is the one, Proxmox 1. And now open the Proxmox to another virtual window. And I'm adding the different node to this particular cluster which was formed earlier. So you can see that my server number 2 has successfully become the part of the first cluster that I formed. So the one is the 192.168.0.102, and this is where like I added my another server also. So finally you can see guys that in my PVCM cluster, which is my Proxmox cluster, I have two nodes which are being visible: 102, 192.168.0.102, 198.162.0.103. Okay. So now when I ask the status, it shows us that there are two nodes which are there into the cluster. You can see bits and bits 2. Okay. 102 is the server in which we created a cluster. 103 is the one which I added later to the cluster. So this is how the web user interface of the Proxmox looks like, guys, that I was talking to earlier. And you can see here that both of these machines are being shown as the part of this particular data center. Okay. Now guys, I'm doing a sudo apt-get update on my server, which is Proxmox number 1, which is okay, I think, which is everybody of you would know. My intention here is now to create an NFS server, and I shall be attaching the same NFS to both the hosts, which is my host number 1, 192.168.0.102 and 103. To this both the host, because we just saw that whenever we have storage is separated from this host, it is always easier for me to migrate. Here we have done the update of the repositories. So we can see here that we have installed the NFS kernel server. So let me just show you NFS kernel server. And now guys, as soon as I done it in sudo apt-get install, it will start installing and it will start downloading until it gets installed. Okay, so there are certain configurations which needs to be done in order for the NFS to be working properly. And here uh, in this etc exports file, I am basically adding the access control to my both the servers, which is server number 1 and server number 2. So all in all, after this particular export backup is being done. What is the meaning here? What is happening is here, both the servers have got the NFS attached to them. That is my final goal. Okay. So now guys, using the NFS, what I'm going to do is I would be uploading a small image. What I'm doing, using this image, I'm going to create a small virtual machine now. Storage to this particular machine is coming from the NFS, and we are running these virtual machines inside the virtual box. Okay. So as you can see, I'm uploading this particular file to the NFS. Now you can see guys, the NFS storage is attached to bits and bits 2. Please note here that bits is one server in our data center. Bits 2 is another server in our data center. When I say data center, it is nothing but the Proxmox cluster is a data center. And both the servers, like I have different hardware servers, both of them are added to this particular PVCM cluster, which is Proxmox cluster. Now, what I will showcase to you is, I will run the virtual machine on one host, which is 102, and I will show you how to transfer that to the host number B, which is 103. Okay. So, first of all, I'm uploading that file, and I have the ISO image downloaded, as I already shown you earlier. The ISO image is nothing but it is the base image, golden image, from which I can launch the virtual machine. All of this work is also done in the same manner in the cloud itself also. But the difference in the cloud is that you have a very good rich GUI, rich graphical user interface, where in the Proxmox servlet you may not have that rich GUI. Once the upload is finished, my dear students, you can see I have the ISO image, which is the content here. So now I will hit the create button, create virtual machine. Please note I am creating the virtual machine on the server 1, which is present in the Proxmox cluster in this data center. I will choose the virtual machine that I wanted to create. I mean to say, I will choose the operating system that I wanted to create in this particular virtual machine. There are the few options that I can choose amongst from, and I'm going to use the image that I just uploaded into my NFS, which is my ISO image. And then I will suggest that how much hard disk I want. I'm suggesting just a 4 GB, which is very minimum to just invoke with. Then CPU, then memory, finally network. And that's how, after I hit the next button, it will launch my virtual machine on the data center, on the server number 1 in the Proxmox cluster. So see guys, as you can see here, you have your virtual machine, which is now being shown here. Sorry. So you can see you have your virtual machine, which is 100 VM1 being shown here on the bit server number 1. So what you can do, you can hit to the console like this, and you can go there. I'm just logging into the console of this, and I can see I have to basically select the boot time, sync, VG option, etc. So finally, it is now booting the kernel up. After the virtual machine is booted and you are basically logged in, you can see the virtual machine number 1 is being started on the host number 1. Remember guys, host number 1 has the IP address of 102. Host number 2 has the IP address of 103. VM1, which is running on the host number 1, has also got a virtual machine address, virtual IP, which is 104. Okay. In the right hand side, I'm also showing you that now the ping from one port is also working. So meaning my virtual machine is up and running, it is reachable, and everything is happening very smoothly. Now, with this in the mind, I shown you how using the Proxmox tool or the Proxmox as a platform, but you can launch the virtual machine. Okay. Now let's see how I can do the migration of the virtual machine from the server 1 to the server 2 using the Proxmox. So guys, once again, see for your reference, this is the virtual machine that I'm talking about, which I have to migrate. I have to migrate VM1 from server number 1 to server number 2, which is my bits 2. Okay, it is just for illustrative examples, guys, that I wanted to show you how the Proxmox can be used in order to do the transfer from one host to another host. You see, I press upon the migrate button, and as soon as I do that, it will ask me automatically that, hey guys, what is the target host you want to transfer me this particular host? So right now it is running on the server number 1, which is 102 IP, and I want to transfer it to server number 2, which is IP 103. That's what it asked. That where is that you want to transfer your virtual machine? And I put the bits 2 because that's what we created for you guys. Now here, as soon as you hit the button, finish button, it will start this entire process. This process will happen automatically and it will take some time. So finally, you can see here, my dear students, the VM1, which was earlier running on the bits server, is now transferred and running very well on the bits 1 under the server number 2. I hope that, guys, it is clear.
It's clear. One doubt I have: migration we did it manually. Is that tool have the capability to configure the automatic migration based on certain conditions?
You're talking about the Proxmox?
Yes.
Can you explain what is automatic migration?
Can we configure something, some trigger in the Proxmox to do the transition of VM1 from the bits 1 machine to bits 2, like based on the load or something like that?
I see. So something like we have the CloudWatch kind of thing you wanted
Yeah.
to say. Of course,
Yes.
yes. Of course, yes. The automatic migration are possible in the Proxmox. and you can configure it, like for example, if a node fails, virtual machine automatically migrates on another node, restarts on another node. Yes, it is possible. For example, if the node is going into maintenance, it is possible.
Okay.
That is basically also called as automatic failover. So a Proxmox HA cluster is smart enough to basically automatically start the VM on the host number B, because now the node number A is dead and there is a problem with that.
Okay. Thank you.
Yeah. Okay. So guys, can you confirm if you can see my new screen?
Yes, sir.
Okay. All right. All right. You want to take a 2-minute break or you want to just start now?
Yes, break would be nice first.
Okay. Okay, 2 minutes. Okay. We'll start at 9:33. All right. So guys, let's get started. All right. So guys, so far we looked into the various features of the cloud, where we saw how cloud infrastructure is supporting the migration, and we also learned that how the virtual machine is considered to be a very fundamental block of any cloud. Now we will kind of prove this by the end of this particular session also, and we will discuss many things which would also rotate around the virtual machines as such. Okay, so now guys, this is how the cloud looks like from outside. If you see, there are various risks associated with this particular cloud. Okay, I'm sure you're able to make the inference from these images. Of course, it is not going to rain or it is not going to fly away, as I indicated in the first slide. But here are the risks which are basically involved. Okay. The question that we have is how to mitigate those particular risks. Yeah. Obviously, you need to have a good management service or a good management layer. And but what is that where there a need for you to manage? So if you look into the cloud, what do we basically expect is we tend to have good amount of clients for which the particular cloud using various services. So it could be some softwares which are being hosted on this particular cloud which are used, or the clients might be connecting to the platform as a service platform in order to develop the application or deploy the application or to make their applications to go to the CI/CD pipelines and things like that. Or things would even go through the lower level also, such as like infrastructure as a service. And the clients itself comes in the various formats. It's not such that the clients can only talk through the web server. They can also talk through some thin clients or through some terminals or through some emulators or some hybrid interfaces. Okay, so your client connections could be of a variety of types which interacts with various services which are there. So what is that you're going to manage? Cloud clients have to make sure how they make their connections or look into the various services. But as we have seen that whatever services we have looked into, they itself form a long list of layers, isn't it? When it comes to the private cloud, I have everything managed by me. That is starting from the networking all the way up to the applications. Okay. So let's not look into the private clouds. Let's look into the other services which are there. That is infrastructure as a service, platform as a service, or software as a service. Again, there are multiple layers as such. It all gets differentiated depending upon who is managing what. What is that you would have to manage as a user? And what is that you have to manage as a vendor? If it is a infrastructure as a service, we know for sure we know for sure what do we know? In the case, what are the responsibilities as a vendor we have, and what are the responsibilities we have as a user? There are certain layers starting from the networking until virtualization, and there are certain aspects which are managed by the vendor, and rest of the aspects, like for example, which operating system you have to install, what kind of middleware you have to install, what kind of binaries do you have to run, what kind of applications you want to run, whether it is a database server or messaging queue which are implemented. So what is all that you wanted to run? Everything is being directed by the user. That is by you, you who would have to manage it. If you have to help with the scalability of it, you would have to help with the configuration of it. You would have to make sure that it is available. That is, you have to provide the high availability. Okay. So it caters to various other details. But if you see that, no, I don't want you to get into the details and I just want to work on my applications. That is, let me just work on optimizing my applications. Let me make sure that it works best on a cloud environment. Then you get into the PaaS. In case of PaaS, most of the details are being managed by the vendor. Of course, its specifications or the runtime environment which are there, which internally would have details with respect to what kind of hardware needs to be run and things like that. But majorly, here you are concerned about the optimization of your application. That is to make sure that your application is utilizing the underneath resources in the best possible level. Also, there are another set of services which are available like SaaS, where you don't have to manage anything at all. You just have to subscribe to various softwares which are there and utilize them. So there are a whole lot of things which are there, and this is something which is not fixed. If it is infrastructure as a service, then it is completely different type of user management. In case you go for the platform as a service, you are going for different type of management. Or if it is software as a service, then you are going for a different set of management. Now, what is there to actually manage? Now, all of you please note here that I'm not looking at this whole thing as external user, but if at all I have to become an implementer of the cloud, what is that I would have to look for? This is what we are trying to drill down here. Now, say somebody decides that they want to build a cloud. Okay. Now they would have to understand as to what exactly goes into the management of the cloud, management of this particular cloud. Okay. What are the various things which are available? What are the things which we would have to manage? What are these things that we shall have to provide as a service? What are the various layers which are actually there? So this is what we are actually trying to get into it now. But my dear friends, it does not stop here because we know for a fact that whatever blocks we have described for infrastructure as a service or platform as a service or software as a service, internally they has to work on the huge amounts of machines. And the top of which you have to have your layer of virtualization, which helps you to create 10,000s of virtual machines. Okay. And it is just not the creation of the virtual machines here. You need to monitor them as well. You need to make sure that where does the virtual machine gets created? How do you make sure that a particular server is not overloaded? How you are monitoring the usage of these resources by the end users? How are you managing the subscription? How are you managing the automatic resource management of it? These are various set of things which comes into the play, which comes into the picture. So all in all, what we see is that there are four layers. Two layers are physical entity, which is nothing but corresponds to the end users, and other side you have the physical machines. So these are the entities which participates as shown in the diagram as two extremes. In between, what do you have? You have a resource allocator and the virtual machines. So SLA here stands for service level agreement. SLA says that so and so user have asked for so and so services to which I am adhering to, and therefore I am also promising for these kind of SLAs. Okay, that's what the SLA talks about. With respect to the SLA, it goes about allocating the resources. It has to manage these virtual machines. Why does it has to manage the virtual machines? Is there any reliability issues? Yes. Any hardware for that matter, you cannot confirm that it is 100% reliable. All of them have their own failure rates. How are you going to handle it? It is not that all the 1000 of the servers are going to come down the very next moment. No, it is not very, it is very unlikely to happen, isn't it? But what is the very likely scenario? There might be 10 servers which might come down on any given day in a year, right? So why is that? Because there are so many physical entities which are playing their role here. Network connection may probably go down as it may not just work. There are too many moving parts over here which can actually go down. So how are you going to mitigate all of those risks? How are you going to bring in the availability factor? How are you going to bring in the optimization of all of these things? How are you going to bring in the scalability of it? How are you going to bring in the serviceability of all of the services which are there? So there are many number of things which are part of what we call in the simpler terms as the cloud. So the key requirement is that you need to definitely have a proper cloud architecture, and just having a cloud architecture may not be sufficient. What is that you need to have? You need to have is efficient management, which is capable of managing the whole lot of resources which are part of the cloud stack. Okay. So you need to have the efficient management piece. The manager which manages these various resources across various service offerings, across various types of users, across various types of physical set of machines that we have. So you need to have this particular management piece. I'm not sure how many of you are repeating this. Oh my God. Anyways, okay. But this is what, like guys, it is consisting of. Okay. So what is cloud? Now again, if we start. So we all agree to the fact that it is an environment which enables virtualization, and it is not isolated to any fixed area. So it is basically distributed in the nature. I mean, we first looked into the data centers, then we looked into the availability zones. And finally, we also looked into the regions in the examples of the AWS. Now the question is whether all of them are present in the same place? No, resources are distributed like that. Not like that you have the storage in one particular region, you have the virtual machines in another region, you have networking in another region, not that kind of distribution. The storage, the compute, the networking, all three major components shall be present by the various regions, various availability zones, or in fact various data centers. Okay. Why do I have that kind of distributed environment? Because the resources are scattered in the nature. Okay. It is no more isolated to the single area. That area could be city, metropolitan, or it could be country. It is not limited to that. Things have gone beyond that. Accessibility have gone beyond that limited scope. Okay. There are thousands and thousands of users or students which could make use of the AWS resources. They may be using the data centers of Mumbai or data centers of Hyderabad. Okay. The customers are known more local in the nature. They're all distributed. The customers who basically make use of business, if that is distributed, how can you be local? So you also need to be spread. You also need to have a very distributed environment which helps to scale, which helps to communicate well. Now, yes, that is a need. Need is fine, but how do I manage all of these things? Management of a data center is a huge, huge task in itself. But now we are talking about the management of multiple data centers, which shall possibly come into some availability zone and multiple availability zone, which could possibly come in a single region. There are so many regions out there available in the whole world. Of course, I'm just talking, taking the example of AWS Hyderabad region or Mumbai region here. Likewise, others also have that kind of facility for that matter. Netflix, apart from the regular set of things, it also has an end user facing thing, something which is workable with the CDNs, right? So how do you really manage all of these things? And obviously there is a need for multi-tenancy as well. Basically, it means supporting the multiple tenants. You take an example of the apartments, like the flats. You have the same area, but there are multiple people using the apartments. Basically, they're using the different services over here, isn't it? As Bits Pilani, we are also clients of Gmail software. There are hundreds and thousands of the schools and colleges out there which are also using the Gmail software. So as a Gmail, it should support multi-tenancy. We are one tenant. Maybe if IIT is using the Gmail service, then that is another tenant. If some other organization like ABC is using the Gmail, then they are also one tenant. So I shall support all of these different users which are coming from different organizations. But can you offer services without maintaining certain standards? Standards in the sense that what kind of services you are providing, what is the grade of the services you are provided, SLA promises that you are making to sure that these services would work well with you. What kind of downtime and uptime you are talking about? What kind of scalability that you do need? So all these things come into the picture where you say you need to not only have the customers, but if you don't provide them the required services in an optimal way, then in no time they're going to wind up the business and then you go away from you. So you need to have the proper management which looks into the SLAs as well. So there is a lot which is needed over here. What is that which makes all of these things easy? What is that thing which has to be there as a part of this distributed cloud environment which makes all of this easy? So this is a question for all of you. Let me know your answers, please. In the chat box. So I repeat my question. What is that thing that I need to bring in such that the things become seamless for me? What is that thing that I need to bring in this kind of environment? I know it's a very abstract question. What I'm looking at it is everybody please answer in the chat box, okay? Uh, all of them, all of you, I want you to be active. So I'm looking at what is that thing which helps me to seamless integration of auto recovery, security, which would help me to manage a hypervisor, which would help me to manage the systems, implement security policies, all of those things. I want everyone to be to be active in answering in the chat window. Please go ahead. Okay. Okay. Funny question. Okay. Good, good. Remaining, please answer. Tanya, Shrikirti Vasan, Ravi, Mohnish, Gautam. Okay, Surosho. Okay, Sivachidambram, Meghna, Niklesh, Yash. Everybody please answer. Varun. Mm-hmm. Raj Sukanya. Bring DevOps. Okay, Ravi, thanks. Okay. Okay. So thank you everyone for answering. I think you all are have answered very good answers. Guys, the first answer that I received from Ajit Yadav is the excellent answer. Yes, we are looking at the automation. Okay. I need to automate the things. Physically, it is next to impossible for me to employ so many people to go and fix the things for all of us and to monitor the resources which are all there, whether physical or virtual. Okay, definitely there is a need for the automation for us to manage this whole lot of things which we just discussed. When I say whole lot of things, it's literally whole lot of things. Now this automation comes into the picture with simple creation of the virtual machine. You give your requirement, you specify your operating system that you want, you specify the machine that you want to start with. You need to specify the security group for the virtual machines and various other things which are specified. And when you hit the launch button, is there something, is there somebody sitting back at the back who is talking all of these requirements and is going to run some specific command and then run this particular machine and post all of these credentials to you? Nahi, no, Papa. It goes to automation. It parses all of those requirements, creates this required resources at the back end, provides you with the information of whatever is you need and require in order to log into the machine, and done. Now from this, we move to the next set of services, which are managed services. I talked about Elastic Beanstalk, right, earlier. So that's how this basically happens. Now, Elastic Beanstalk is like it comes like a function as a service or like managed service, which is a wonderful service where you don't have to bother about what happens in the background. So you just have to bother about your code and then deploy it. Once you deploy it, it automatically looks into the aspects such as how would it gonna be scale, how it needs to add to the services, various details which are automatically being taken care of. But who's doing all of that? Who's doing all of that? Obviously, this is being done by the automation scripts. The whole cloud is built together on the support of automation scripts. Now, it's not just about automation scripts which are working. There are hypervisors, there are monitors, there are many other entities which are all there, but they're all tied together in a particular format using the automation. So, what is that we need? We need virtual infrastructure managers. There are multiple of them. Some of them are proprietary, like AWS. There we do not know much of the internal information as such about them. There are others as well, like OpenStack. This is one of the virtual infrastructure managers. It helps me to manage my whole infrastructure. It helps me to manage my whole infrastructure, likewise we are going to also see in the Open Nebula. Proxmox we saw in just now, right? It is also a way in which the virtual, in a way, like a virtual infrastructure manager, because it helps me to manage my resources. I have physical resources and I can bring in the virtual machines. I can bring in a networking. I can attach storage to it. I can do migration. To what level it is possible? This is debatable, guys. But for OpenStack, for any private cloud operator who's there, the open source competitor for all of this is OpenStack. They have near to about like 50 to 60 type of services, which we have got added to this. Okay. So what is the virtual infrastructure manager? In the beginning, I said virtual machines. What is this VM? Why do I require a VM? So you talk about a kind of service. Fundamentally, if you need any kind of compute environment, it has to go back and sit on some virtual machine. You talk about some elastic map reduce. It is basically a Hadoop system, right? What does it do? It stores the data in some nodes. It stores the data in some nodes and you provide the task of the type, map, and reduce. It is going to help you count some particular identification like word count or finding out a sales indication of various companies and a lot of things like that, etc. Right? But all of these things have to run somewhere. Where it has to run? On the virtual machines. You deploy an enterprise application. When you run an enterprise application, obviously there are a lot of things which might be required. What are those? The first one is web servers. Where does those web server runs? They runs on the virtual machine. Second one is the databases. Where do you install the databases? They run on virtual machine. Obviously, now we do have an alternative in the form of containers. But there also, what we see is that these containers also run inside the virtual machine. Okay. So you talk about the Lambda, which is function as a service. This again runs somewhere on some virtual machine. Obviously, this is not visible to the end user. So you talk about the RDS, guys. This is also runs on the virtual machine. Anything where you might need some kind of computational support, a virtual machine is required. Okay. So I would definitely consider a virtual machine as the building block of any application which is cloud native or cloud hosted. Okay. So there is a whole lot of things supporting the virtual machines like that. Here, first I want to create a virtual machine. Here, what do I create? Where do I create it? Obviously, there are so many hosts which are there. You may go ahead and launch the virtual machine on any of the host. You may go ahead and launch the virtual machine on any of the host. Then is that the call that you wanted to make? Obviously not. You would not like to make that call, huh? It needs to be very optimal decision, which would be able to optimize the server resources in a best possible way. It cannot be just a random call which you can take, right? So how do you want it to schedule? How are you going to look into the resources which are used by this VM? Of course, by monitoring it. So where do I put it? This is the first question. Next, how do I provision the new cluster node? What is this new cluster node? How do I create the clusters? Cluster in the sense that group of machines which comes together to form a service, right? Can I clone them? Can I bring in a set of it? How do I scale them? So there are a lot of questions related to that as well. Of course, there is a third question as well, that I have created a VM, but just creating a VM is not sufficient. Okay. I would install the applications in that. And just running the applications is not sufficient, right? Obviously, someone have to make use of the excuse me. Someone have to make use of the applications which are running, the resources which you have installed, the databases which you installed, some messaging queue, ActiveMQ, or some middleware that you installed, whatever like that, right? So obviously it has to communicate. If it has to communicate, then what does it require? The minimum set of things like IP address. Where is the IP address coming from? Do I need to make a person? Do I need to make set a person and say that this particular VM is created and then, hey, give one IP to this, give one IP to that. Okay. Even this person will give the IP address, but he will ask what subnet to be used. We will tell the answer as VLAN. Then he may ask which VLAN, which bridge needs to be attached. How many bridges are required? To which pool from do I need to make an IP address allocation? So there are a whole lot of questions which are associated. And all of these questions gets answered with one thing which is called as automation. So you give basic details, basis of which the thing shall be picked, and you're going to have a virtual machine ready in the no time. So scheduling, monitoring, monitoring, cloning, networking, all of these things are part of a huge infrastructure which needs to be managed. So this VIM, what it basically provides? It provides a uniform view of resource pool in front of you. Okay. So you see this AWS Cloud, a console, it gives you the user interface, which will help you to interact with various services which are there in the offering. It helps you to monitor the resources. It helps you to create the budget. It helps you to look into the cost. So this single interface would help you with so many added agenda items as a part of the management of the cloud. Apart from this, yes, of course, there are various basic things. It shall look into the lifecycle management and monitoring of a virtual machine, which I have already told you. It also tells on how should you integrate the things. The image which is used to for creating a virtual machine, the network which is used to create the communication facilities between the virtual machine. Of course, the virtualization enables the creation of this VM as well as storage. Okay, so as you can see, we have Open Nebula, which is a VIM which runs on the top of hypervisor. Please note here that hypervisor is not separately installed and Open Nebula is a not separately installed. Open Nebula has basically those drivers related to hypervisor, which you can select, which would further enable virtualization on your hardware. Finally, the virtual machine can be launched on the top of the virtualization layer. So this is so this is one half piece, guys. I would basically say how can we see or extend the benefits of virtualization to the clusters. So you have cluster of machines. What is that virtualization brings to these clusters? So here what I can basically expect is that the design should basically consider that all of these VMs are replaceable or redeployable. Okay. So in this cluster of machines, you would expect the deployment to happen or redeployment to happen or migration of these machines to take place. So the virtualization helps us to provide a very flexible and agile virtual infrastructure in the place, which we can work with various resources in a seamless way. Clusters can act as a backend for a public cloud. So I have my certain things which are running in a public cloud, but I could also have a cluster of machines which could provide some sort of backend support to the public cloud. Okay. Or it could even act as a private cloud where it can use your storage as well as your compute capabilities which are there in order to set up a private cloud. Okay. And the difference between the first one and the third one is that the first one is just acting as a storage backend, whereas the whole front end is being installed in the cloud. When I talk about the third one, which is how the cloud operates, how are we talking about the, here we are talking about mostly about like the cloud bursting kind of things. The cloud boasting is I have my private cloud installed using the resources which are there, but resources are limited in the nature. I mean, I cannot compare the resources quantity which are available in the public cloud. At some point of time, if there is a need for me to extend beyond my cloud private cloud, then we get into the cloud bursting where I immediately gain access to the private public cloud and start using the resources which are available out there. That basically means on-demand access to the public cloud. First one, I have my resources. I have my application which is already running in the public cloud, but also now it requires a secure backend, and the backend I'm using in my private storage. So the networking, the image management, and the virtualization, these three forms the main three pillars of distributed computing, distributed management system of the cloud. Okay. So from here onwards, my dear students, we shall be looking into the internals of the virtual infrastructure manager. As I said earlier, we shall be using this particular tool called as Open Nebula as a case study in order to study about the virtual infrastructure manager. which we would study in the next lecture onwards. Okay. So we will take a logical pause here, my dear students, and then we will cover the open nebula and related information in the next lecture. Till then, I will take a quick pause now. If you want to ask some question, if you want to ask some a doubt about assignment or anything else or related to what we have covered, please go ahead and ask your question. Thank you. Go ahead,
Yeah,
please.
hello, sir. Yeah, so for the EC1 part, we'll be having two quizzes, right? Is quiz one and quiz two. The
Mm.
quiz one was taken, quiz two is what not taken. So when it will
Yeah,
be taken?
we are going to start the quiz to maybe in some couple one of weeks. Maybe this week I am going to start that.
Okay. And another question is the for assignment part, we'll be having one live demo project we did, and we submitted the report also on the mail. So the activity we perform on the cloud or the URL that we use for the application and all that. So could we dismantle this or will we keep it for some times?
Uh, you're talking
The
about what?
servers, the servers, the Jenkins, and the live project URL, all this.
Yeah, so you should keep it hosted. So I'm going to evaluate them. I'm going to see all of them, and then probably we would be able to see all of that.
Okay, sir.
Okay, so just keep it live for some of the time, I would say.
Okay, sir. Yeah.
Yes, sir. For a demo, any slots we can get at any suitable time.
So today,
Today after sometime we are having network foundations, so
what time your classes is getting over?
it will be over by 12:30.
After 12:30, you don't have the classes?
No, there is a gap, and again we have class. I mean, from around 6 to 7:30, something like that. Evening.
Uh,
8:30.
so you're saying that you have the classes till 7:30?
Yeah, evening one slot, 6 to
8:30. 8:30.
8:30, right?
8:30.
Okay.
No, what time are
But
you guys available? What time are you guys available? What time are you guys available?
sir, from group 14, I think we are telling. Is it group wise? We'll be having some slot or a common call.
No, no. See, as I told, so this is something like not like a mandatory stuff. So as I told that we can just have it if I really want. Maybe you can just record this demo and send it to me across. But if you really
Okay.
think that hey, maybe it is great that something that we developed and we would like to personally talk about it, then yes, I'm all in, and we can maybe chat sometime today. So I'm busy from 1:30 to 3:30. I have another class, and any other slot you if you want, you can take it up.
Yeah, so yes, sir, we have recorded the video and of 30 minutes of the live demo, how it is working, and we have sent it on the mail itself.
Okay, cool. That
Okay, sir.
makes
Then
sense.
recording also we can create and send over
Yeah,
the
yeah,
email link.
you can
Okay.
send a
Yeah. Okay.
recording. Okay. All right then. Thank you, everybody. Any other doubts anyone would like to ask, please go ahead. Okay, if there are no doubts, then we can just call off this lecture. Thank you, everyone, and I'll see you in the next lecture. Yeah.
Thank you,
All
sir.
right. Bye bye. Thank
Thank
you
you.
and take care.
Thank you, sir. Thank you.
Thanks.
Bye.
Thank you.